Hello, this is Mr. Fitz, and today we're looking at polynomials, in particular adding, subtracting, and multiplying. But what I want you to see is when we're really working with polynomials, we're working with something very familiar to people, which is what I call the cash register. So here I have a cash register, which many of you will see over the course of your life. And the idea with the cash register is if a customer pays you with just a bunch of change, you don't just throw the change in and say, thank you very much. You have to sort it out because you have to have an understanding of what was just given to you. So when you're given change that's different bills or different coins, you take all of your pennies and you put them in the first slot, and then you take all of your nickels, you put them in the next slot, and all your dimes in the next slot. You just sort out the coins that were given to you. So this is a very typical process that you'd be used to seeing if you're someone who worked on a cash register. For the purpose of when you come to count these things and you're trying to figure out how much you have at the end of the day, everything that is this slot are pennies. Everything here is nickels. So you know what to expect from it. You've sorted out all of your coins so you know what you're doing. Well, the same thing happens with polynomials. So when I give you polynomials to add together, instead of pennies, nickels, dimes, instead of $1 bills, $5 bills, $10 bills, you're going to be looking at numbers, x to the first power, x to the second power, x to the third power, and so on. So if I now bring up a problem which you're likely to see, something that looks like this, where I have 7 plus 4v minus 4v cubed, plus 5v cubed minus 4 minus 2v. All you're going to do is take those things and sort them into your cash register. So if I look at that same problem I just gave you, here's my 7. I'm going to put that in my first slot. And then I have 4v. Well, that has a v on it, so that's going to go a slot over. That's not the same as 7. Negative 4v cubed. I need to skip over my squared slot and put the 4v cubed in there. Now when I go to add my second polynomial, I see that I have another v cubed. I'm just going to put that in the same cash drawer that I had the other v cubed, because it's the same type of bill. It's the same type of coin, so I'm putting it together in that slot. I have another number that's just a number, no variable component, so I'm putting it with the others. And then v, I'm going to put it in my slot that just has the exponent to the first power. So now that I've sorted, I call it sorting the polynomial. Now I have a chance to actually answer the question. So if I go back to what I'm actually looking at in my original problem, I can now look at my biggest bills, my largest coins, and sort those out first. So when I look into my cash slot at that place where I have the largest coins, I had a 5v cubed and I had a negative 4v cubed. So if I tally that up, 5 minus 4 is 1. So I know that my answer is going to be 1v cubed. Now I go to my next most expensive, highest price coin or bill. That was my v's. Negative 2v plus 4v. If I add those together, 4 plus negative 2, I get 2. So I know that 2v would be part of my answer. And then the last thing, which was like, were my numbers. I had a positive 7 and a negative 4. So when I put those together, I get 3. So if I then go through and list my answer, I now have the ability to answer the question. I can just write out what my 3 answers were, and that's what we end up with for our answer. So all we do when we're adding polynomials together is sorting them. We're just putting them together based on type. So if I look at problem number 3, I'm going to put negative 4r squared and 6r squared together because they're both the same bill type. It would be like both of them being $10 bills. So I end up with negative 4 plus 6. I end up with 2r squared. And that's what I'll lead my answer off with. If I look to the next one, I have negative 2r, but I have another negative 2r that makes negative 4r. And then I have two numbers, 6 plus 6, that's 12. So just think of the cash drawer. Think of sorting these numbers out based on the exponent type. Same thing happens with subtraction. You just have to be careful to change your signs first. So if I were going through this, I'd want to make sure I was taking 7 away from the drawer. If you're going to use the cash drawer analogy, it's probably a good idea to just add the opposite. So you'll see in the directions, add the opposite. So instead of putting 7 in the one slot, I'm going to put -7 in there. Instead of -4 in the R to 4th cash slot, I'm going to put +4 because I'm adding the opposite. Instead of doing -4, I'm doing +4. Instead of doing -3, I'm going to do -3. And that's going to help me be able to count what's in all of my cash drawers. Now, the only other thing that you're going to see as we go through the sheet is multiplying polynomials together. And that one's a little more complicated to see with the cash box. So I'm going to close that for a minute. And instead, I'm going to bring you to this online applet that you're going to get a chance to practice with today. So let me bring open this. It's the area model, and it just helps us see what's going on a little better. So I'm going to click on that. It's going to load up this interactive simulation, and we're going to find out how it works. There is Explore, but I'm probably going to go just straight to the game here so that you can see how it interacts. Let's make it a medium challenge, and let's see what we can do here. So on the medium challenge, they're going to ask us to fill in parts that are missing. So if this is supposed to be x minus 6 on the top, we have the x, but we don't have the -6. So we'd have to put the -6 into the area model. I'll hit enter, and then we're missing, it's supposed to be x minus 1, but right now I just have the -1, so I've got to get the x in there. Now I've represented what's going on, and you can see that really what's happening is 4 products. So in this process, I'm going to have to do 4 multiplications to make this turn into this. So x times x, here's my x squared, x times -6, -6x, -1 times x is -1x, -1 times -6 is 6. And then because these are both x terms, I add them together to get -7. That's why we're getting this here. And then we can check and see that we did it correct. Now, if I go back and look at all the different things I could do, maybe I'm going to hit the back button and I'm going to say, I didn't know what that was asking me to do. Let's start at level 1 and just make sure I understand the basics of the setup. So I'm going to go back to the game this time, and I'm going to start at level 1. This time they gave me some setups. They said 5 is the number, and I'm multiplying by x plus 1. I'm going to use distributive property. 5 times x is 5x, 5 times 1 is 5. So they're just trying to get you to see what distributive property is, get a chance to try it. If I go to the very hardest level now, let's just max it out. Let's see what the hardest possible thing I could do in this is. Because it's always fun to find out what the most challenging problem is. I enjoy that. So they've said they didn't tell me what was supposed to be up at the top for the side lengths, but I'm going to guess based on this area model. I had a 1 down here, which means it could be 1 times 1. But it could be -1 times -1. Let's say it starts with 1 times 1. Because 1 times 1 is 1, I know that to be the case. If I did that, I would have gotten 1 times x is x, and I would have gotten x times 1 is x, and they would have had x plus x is 2x, so I feel really good about it. Woo! Even on the hardest level, able to get there. That is good. That is a nice one. Oh, they gave me a new model this time. It's supposed to get to 12 now. So now I've got to think of ways I'm going to get to 12. Well, 3 and 4 is a good way to get there. So let's plug in a 3. Let's plug in a 4. And then let's see what I have. That would be 3x, and that would be 4x. And when I add those together, I get 7. The problem is I'm not supposed to be getting 7. I'm supposed to have a -8 here. So I'm going to know that 3 and 4 just didn't do it for me. 3 and 4 couldn't have been the right answers, because those are adding together to give me 7, not adding together to give me 8. So let's see, how else could I get 12? 1 times 12, that's not adding to 8. Oh, what about 2 times 6? 2 times 6 would give me 8. So now I have 8, but that's a -8. What if I made this negative and this negative? If I made them both negative. Now I'm getting -8 when I add those together, but a negative times a negative is still a positive 12 at the end. So now I'd know that I have it. So that's what you'll be doing just to try to figure out what's going on. What they're really doing is distributive property. They're doing a series of multiplications on this one. So if I went back one more time to that other screen, if I go back to something like this, what we see is that we're going to do 4 products for these problems. 2 times 3n, 2 times 8, 7n times 3n, 7n times 8. That's going to be 4 products, and when I list them out, I'll be able to get to an answer. Down here, you're going to see it got a little longer. If I do distributive property, 2 times 6x squared, 2 times 4x, 2 times 2, there's 3 products. And then I have to do 3 more. 7x times 6x squared, 7x times 4x, 7x times 2. That's 6 products that you're going to end up with there. So if I'm doing that one, it's going to take a little more time. But that's okay, because we have enough time to go through and just make sure we understand what's happening with it. And what I'll do is I'm going to do that one out on the whiteboard so you can see what I'm talking about when we do 6 products, because that's a lot to kind of manage in your mind. So I'm going to go back to my screen here, and here's my setup. So what I'm going to do is I'm going to take that 7x. If I go back to that problem again that you saw, it was supposed to be 7x plus 2. So I'm going to put the 7x plus 2 on the side, and then 6x squared plus 4x. 6x squared plus 4x. And then I believe it was minus 2. I better check and make sure before I do a little problem. It was plus 2. And all we're going to do is those 6 multiplications that I see inside the boxes. So 7 times 6 is 42. Again, we add exponents when we're multiplying. That's what we just came out of from last unit. Great. 7 times 4 is 28. I'm adding the exponents of 1 and 1. 7 times 2 is 14. I don't have any variables over here, so I just keep the x that I had originally. And then I go do my last 3 multiplications. 2 times 6 is 12. And then I'm going to do 2 times 4 is 8. And then I'm going to do 2 times 2 is 4. And then to get my final answer, I just have to look at my cache box. I need to sort everything out. I've only got 1 x to the 3rd power, so that's going to stand alone. Nothing's going to be able to change that. And then I'm going to look for my x squareds. Here they are. 12 and 28 would make 40. So I know I'm going to have 40 in my x squared cache slot. And then I'm looking at my x terms. I have 8 and 14. That means I'm going to have 22 in my x cache slot. And then the final number of 4 stands alone. So now I have my answer for the multiplication. So that's how I'm going to deal with any of these multiplication problems. I'm just going to think of it as an area model problem. If you're very good at doing multiplication in your head, you could just use distributive property twice and get these listed out just as 6 products without having to set up the box. But I love the box. I set up the box because it helps organize my thought. So I am not against that at all. Good luck with your assignments this week.